A very, very good evening to you all, and welcome to today's session. A continuation of our IP version 4 and IP version 6 addressing, as well as subnetting class of the CCNA1 training course. Okay. Today we are going to be continuing from where we stopped, and we'll be looking at IP version 6 address types. And here, if you remember yesterday, in the class we saw that we have different types of packets, okay, where we have unicast, multicast address, and a broadcast address, and that is for the IP version 4. For the IP version 6, we still have the unicast, the multicast, but we do not use broadcast for IP version 6. We use what we call anycast, right? So the unicast uniquely identifies an interface on an IP version 6 enabled device, while the multicast is used to send single IP version 6 packets to multiple destinations like we have seen yesterday. But for the anycast, it is any IP version 6 unicast address that can be assigned to multiple devices. A packet sent to any cast address is routed to the nearest device having that address. And the reason that is done is to limit and control this issue of broadcast that we have. So unlike the IP version 4, IP version 6 does not have broadcast address. However, there is an IP version 6 all nodes multicast address that essentially gives the same results. Okay, same results. Let me see. Okay, now how about the prefix length? Remember, we said that IP version 6 is 128 bit long. And because it's 128 bit long, we have what we call, in the IP version 4, we know we have what we call the network portion and the host portion of the IP address. So the prefix length in IP version 6 actually is represented in this slash notation and is used to actually indicate the network portion of the IP version 6. And when we are talking about the network portion, we're talking about like the surname, like the family name, okay? We're talking about the aspect of the IP address that that everybody within that LAN or that local network is going to possess. All right, so here is represented with this prefix length, or in IP version 4, we call it the slash notation. So the IP version 6 prefix length can range from 0 to 128. Why? Because the entire IP address is 128-bit long. But the recommended IP version 6 prefix length for local area networks and most other types of networks is 6/64, which means that the IP block is divided into two, /64 for your network portion, /64 for your host portion. All right. That is this is your prefix length for network portion. This is your thing for the host portion. So most IP addresses for IPv6, if you are going to be using, you're going to be using /64. So it is strongly recommended to use a 64-bit interface ID for most network. This is because the stateless address auto configuration uses 64-bit for the interface ID and also makes subnetting easier to create and actually manage. Now, we have different types of IP version 6 unicast addresses. So unlike the IP version 4 addresses that have only a single address, the IP version 6 addresses typically have two unicast addresses. We have the global unicast address, which is similar to the public IP address that we have when we're talking about IP version 4. And they are globally unique, internet routable addresses. And that's why they use the word global. So they are global unicast address. Then we have the link local address, and they are usually required for every IPv6 enabled device and used to communicate with other devices on the same local link. Okay, and the link local device or address are not routable and are confined to a single link. So you see, it's like the public and the private that we saw in the other one. Okay, so we have the global unicast and then we have the link local. But now, if you look at the IPv6 unicast address, okay, you have the global unicast, which we looked at. We have the link local, which is, we say, is like a private. Then we have the loopback address. The one that we saw is the IP address of the network interface card. Then we have what we call the unspecified addresses. We have the unique local addresses. We have the embedded. So we're going to see some of these addresses. We'll talk about them very soon. So the IPv6 unique local address ranges from FC00 /7 up to FDFF /7. And they are like the private IP addresses that we have, but they have some significant differences. All right. One is that the unique local address are used for local addressing within a site or between limited number of sites. Okay, and then they are also they can also be used for devices that will never need to access another network. Okay, then they are not globally routed or translated to a globally IPv6 address. So many sites of the private nature address attempt to secure and or hide their network from potential security risks. This was never intended in the beginning. Okay. Then under the global unicast address, we said they are uniquely routable on the internet, and it is usually the first 3 bits of 0001 or this one. Okay, they are being assigned 2000 /3. Okay, what we are saying is out of this 128 bits, all right, and then this first 3 bits in binary are the ones that actually give it. So the current available global unicast address begins with a decimal 2 or 3. Okay, that is actually only 1/8 of the total available IPv6 addresses. So you see, they just picked 001, and then in binary, this is it. Okay, so 001. So anytime you have a global unicast address that begins with this, then you know that that's a global unicast address. Okay. Now, what is the structure of this global unicast address? The global routing prefix is the prefix or network portion of the address that is assigned by the provider, such as like the ISP to the customer side, or the global routing prefix. You know, it will actually depend on the policies of the ISP. Then you have the subnet ID. Okay, the subnet ID, where you see it here, this is like the global routing prefix, the subnet ID, then the interface ID. Okay, and now if I divide like this one goes basically one side, this one goes basically one side, because this is like the network portion, this is like the host portion. So we are saying that the subnet ID field is the area between the global routing prefix and the interface ID. So the subnet ID is used by an organization to identify subnets within the site. You know, before we close today, we're going to look at how you can do this subnetting for IPv6, and we will need to understand this area of subnet ID. Then the interface ID the IP version 6 interface ID is equivalent to the host portion of the IP version 4 address. It is strongly recommended that in most cases, /64 subnets should be used, which creates a 64-bit interface ID. Okay, so basically that is it. So we have the global routing prefix, the subnet ID, and the interface ID. How about the link local address? An IP version 6 link local address enables a device to communicate with other IP version 6 enabled devices on the same link and only on that link. When we say that link, we're talking about that subnet. So it does not go out of it. So it's like within the same LAN. Okay. So packets with source and destination link local address cannot be routed, which means once they get to the interface of the router, they cannot go out. Okay. So for instance, now you see if I have a switch here and then I have PCs, then I have a router here, then I have a PC here. Now, this is PC 1, 2, 3, 4, 5. This is 6. What we are saying is that link local address can talk from PC 1 to PC 2 to PC 3 to PC 5. But it cannot go to PC 6. Why? Because once it gets to the router here, the router will drop it. That IP address is not routable. So if link local address is not configured manually on the interface, the device will automatically create one. Okay, so the IPv6 link local address begins with FE80 double column /10, right? Now, let's look at how to subnet IP version 4 network. To understand the concept of networking, subnet, you need to understand the concept of binary. So network are most easily subnetted at the octet boundary. Okay, when we say octet boundary for IP version 4 now, we have left IP version 6. For IP version 4, the octet boundary that we are talking about is each of the octet. All right, you see there is /8, /16, /24. All right, why? Because you see, we said it has 4 octets. See, it has 4 octets. Yeah. So each of the octet has 8 bits. So the first octet is /8, second one /16, the third one /20 /24. Okay. So for us to understand the subnetting very easily, we have to look at the octet boundaries. All right. So if we say /8, we mean 8 bits are on, are 1, or we say they are on, or things like that. Okay, 8 bits are on. And anywhere you have 1, that means it is a network portion. You see, if you look at this one, you see all these N. It means it's a network portion. So if you have a /8 in your IP address, it means 8 bits are actually 1 in the network portion. Then the remaining 24 bits are off and they are in the host portion. That is why you see H for host. All right. Now, which means how do we know the number of host devices that this block can give? You just do 2 raised to the power of this 24. You will get this. All right, you'll get like 16,777,214. This is the IP address you get for each of the subnets in this particular /8. If you come to /16, that means you see these first two, the first and the second octets are on, and they are for the network portion. That means the remaining 16, they are for the host portion. And if you do 2 raised to the power of 16, you should get 65,534. That will let you know the number of IP addresses for each of the subnets that you have in this block. If you do /24, it means that the first 3 octets are on. All right. They are all on the network portion. And then the last one is off, which is for the host portion. And if you do 2 raised to power of 8, you will get this. Now, if you observe this, and this, there is, if you do the arithmetic that I'm telling you, you will see that there is -2. There is -2. Why? Because there's a formula called, okay, n is equal to 2n minus 2. Now, this formula is what is used to calculate your number of hosts or number of networks in subnetting. This -2 is saying that for every subnet, there is a network portion, there is a broadcast address. There's a network address, there's a broadcast address. And so for you, and the network and the broadcast address are not usable IP addresses. You cannot use them for your host. And that's why you need to minus them at the end of the day. So if you do this one, 2 raised to the power of 8, you should be able to get 256. If you do -2, you should get 254. The same thing here. There is a -2. The same thing here. There is a -2. All right. So on this particular formula, this n that is at the top here, what is the value of this particular n? This n here is like the number of zeros that you have in your host portion. And then this 2 here is telling you are dealing with binary. All right, you're dealing with binary, right? So we will see how we will apply these formulas very, very soon. So if we look at this table, in the first table, we have 10.0.0.0/8 is subnetted using a /16, and in the second table, a /24 mask. Now, it looks very, very cumbersome, but we will find a way to make it very simple. All right, because you have this table here, okay, and you have this 10.10.10.10.0.0.0/16 from, this is the supernet, and then it is subnetted into /16/16/16, and you see that the values in the /16s were changing is in the second octet. You see the second octet, it starts from 0, 1, then 2, then 3, then 4, then 5, then 6, then 7. You see it continues like that. Okay, so but that is like for /16. We're going to get that. But if you come to this one that is for /24, this table here, when it is subnetted, you look at the values that are changing is in the third octet. It's in the third octet. Look at this one, .0, .1, .2, up to you get .255. That is like how /24 works. So we will show you how we can get there. Now, if I have an IP block and I need to subnet, like I said, you must first of all understand the binary arrangement. And in the binary arrangement, you have a 32 bits. And within this 32 bit, you need to understand which portion is the network portion, which portion is the host portion. And when you are subnetting, the idea of subnetting is just dividing. It's like you're dividing, like you're partitioning, you're like separating. Okay, so you cannot separate what you don't have. So if you have maybe 200 computers, then you can divide them into 2 to say, okay, 100 comes here, 100 goes there. You see, you cannot say I have 200 computers and I want to divide them so that I have 200. No. So in subnetting is the same way. You are only subnetting based on the IP address that you have. The IP address that you have, that you are given, will tell you the host, the number of hosts available for you. Then you can decide to subnet. In yesterday's class, we talked about what we call the subnet mask. And we said that the subnet mask identifies the host portion of every network. Now, that subnet mask is what is called the slash notation or the prefix length, okay, that identifies the network portion. For instance, if I have a subnet mask 255.255.128, that's a subnet mask. The prefix length or the slash notation is going to be a slash 25. How did we get slash 25? All you need to do is count the number of 1 here. You see the first octet, which is 8 bits, is full. The second octet, which is 8 bits, is full. The third octet, which is 8 bits, is full. That is 24 bits. Then there is a 1. Can you see? There is a 1. So, which means that the number of ones that exist on this particular block is what is termed the prefix length or the slash notation. So how about the number of zeros? The number of zeros tells us the number of hosts possibly you can possibly get. For instance, since you see here is a slash 25, you have how many zeros? You have 7 zeros left. Now, out of these 7 zeros, how do you know the number of hosts that it can serve? All you need to do is 2 raised to power of 7 minus 2. Remember that formula? 2 raised to power of 7 will be 128. Minus 2 will give you 126. That is how this 126 is gotten, as the number of hosts that are gotten there. How about the number of subnets that you can get from that block? How many bits have been borrowed? If you observed from the normal notation is a slash 24, but you see there's 1 bit that has been borrowed. You see it, that is thick there. Since that 1 bit have been borrowed, it tells you the number of subnets that this block can be created. So you just do 2 raised to power of that 2. That will give you, 2 raised to power of 1. That is 1 bit was borrowed. 2 raised to power 1. So that will give you 2 subnets. And that's why you have 2 here. Let's go to another one, slash 26. Now, remember, we're doing this from the subnet of slash 24, which is the supernet, okay? Now, when we have slash 26, this is the subnet mask, all right? Now, within the subnet mask, you will see that how many bits were borrowed? 2 bits were borrowed. Where are they borrowed to? They are borrowed to the network portion. That means how many bits are left? You are left with 6 bits. If you do 2 raised to power of 6 will give you what? 64. Minus 2 will give you 62. That's how you got 62 here. How many subnets can be gotten from this block? How many bits were borrowed? There are 2 bits that are borrowed. So if you do 2 raised to the power of 2 will give you 4. That's how you get 4. Now, I want you to observe, as the slash notation increases, 27, 28, 29, 30, as the slash notation increases, you will see that the network portion, the number of subnets that it can give you increases. And then the number of hosts that you can get decreases. If you observe, you see that it decreases. Because in this particular aspect, the number of bits borrowed tells you the number of subnets that can be created from that block. Then the number of zeros that are remaining tells you the number of hosts that you can actually get from it. Okay? Now, if we are doing subnetting for slash 16, all right, slash 16 is going to be in the 3rd octet. Okay, we have done for, this is slash 24. Where is slash 24? This is slash 24. So slash 24, that means the first 24 bits are already on. And so we worked on the remaining. For slash 16, it means the first 16 bits are already on. All right. So we're going to look at the remaining. we're going to be seeing how many bits are being borrowed. Okay, so you see in this first segment, how many bits are borrowed? 1 bit is borrowed. 1 bit is borrowed. And if 1 bit is borrowed, it becomes /17 because we're looking at /16. So 1 bit is borrowed, you add it to the main block, so make it 17. Then how many subnets do you have? 2, because it's only 1 bit. So 2 raised to the power of 2, 2 raised to the power of 1, sorry, is 2. How many zeros do you have? You have like 15 zeros. So if you do 2 raised to the power of 15 minus 2, you should get this particular value, 32,766. If you do /18, so now observe the subnet mask 255,255, the values that are changing is from 1 to 8. All right, the next one, 192, 224, 240, 248, and it goes like that because of the number of bits that are borrowed. You see, so as the number of bits that are being borrowed increases, the number of subnets increase down the ladder, and then the number of hosts decrease down the ladder. So that is how it works. Now, there are 3 things that I don't want you to forget. Number 1 is how you actually get your slash notation. Your slash notation or your prefix length, this one, your prefix length or your slash notation is the number of bits that are on, or which is 1. They are 1 or something like, or they are on. If you get that number of bits are on, that is very good. And you get that from your SuperNet. The next thing I don't want you to forget is how you get your subnet mask. How you get your subnet mask. All right. Then the last thing you should not forget is the formula we're talking about, because the formula will tell you based on the number of hosts that you're going to get or the number of networks that you're going to get. So if we are to create 100 subnets with a /16 prefix, how do we do that? Now, I have an IP address 172.160.0. This is, for instance, a particular subnet, okay? And then we are supposed to create 100 subnets, okay? I'm not talking about 100 hosts, though. I'm talking about 100 subnets. So you see there are 2 things, the number of hosts and the number of subnets. The number of subnets tells us the number of bits that we are borrowing. The number of hosts tells us the number of the zeros that are remaining. So if we are to get at least 100 subnets, then we should just do a question. It says that you ask a question, 2 raised to the power of what will give you at least 100? At least 100. So you do 2 raised to the power of 7. 2 raised to 7 will give you 128. So what is this 7 in this case? This 7 is the number of bits that you're going to now borrow. So we are going to now borrow 7 bits. Okay, so you will borrow bits number 1, 2, 3, 4, 5, 6, 7. If you borrow 7 bits, it's going to now give you at least 128. That is why you see here borrowing 7 bits. So that means we're going to turn 7 bits to be on. So the question is saying creating at least 100 subnets. Okay, because you can be asked to create 100 hosts or a number of hosts, or you create a number of subnets. Now, say consider a small ISP that requires 1,000 subnets for its client using network address. So you have a supernet of 10.0.0.0/8. All right, and you are to create at least 1,000 subnets. So for you to do that, you need to say 2 raised to the power of what will give you a minimum of 1,000. And then here, 2 raised to the power of 10 will give you 1,024. So what is this 10? This 10 is the number of bits that you're going to turn to be to be on. All right, 10 bits. So if you count from here to here, it will give you 10 bits. So if you do that, the remaining will be 0. So it will tell you the number of hosts that you will get in each of those subnets. Subnets to meet requirement. So when you are subnetting, you have to subnet to meet the requirement of your need or your organization. So enterprise network will have an intranet, maybe a company's internal network, typically using private IP version 4. Okay, all right. Or may have DMZ, a company's internet facing servers, or devices in the DMZ may also use public address as well. So a company could use 10.0.0.8 and subnet on the /16 or the /24 network boundary. Okay, so you may have this block and say you want to subnet and it's /16 or /24 network boundary. So the DMZ device would have to be configured with the public IP address. All right, so there are two considerations when planning subnets. One is the number of host addresses required for each network, and then the number of individual subnets needed. So if you are doing your boundary from a /24, then it will tell you how many bits you need for host and how many bits you need for network. Okay, if you are doing your own from a /16 boundary, then it tells you the number of bits you also need for each of it. Okay, now we have an example here. A corporate headquarters has been allocated a public network address of 172.160.0/22. Now, you see, when they say this /22, what does it mean? It means 22 bits are on in the subnet mask to identify the network portion, right? And if 22 bits are on, how many bits are off? You will now do 32 minus 22. You will get what? 10. You will get 10. That is how you get 10 bits for hosts. Because 22 bits is for the network portion, 10 bits for the host. So if you have 10 bits as 0, look at it here, the network portion, 10 bits. How many hosts can you have? You just do 2 raised to power of 10 minus 2 will give you 1022 hosts. Because you do 1024 minus 2, which is minus the network address and the broadcast address, you will get 1022. Okay, so that is what you will get. So a corporate headquarters has been allocated a public network address space of 172.160.0/22 by its ISP providing 1022 host address. There are 5 sites and therefore 5 internet connections, which means the organization requires 10 subnets. With the largest subnet require 40 addresses. So it allocated 10 subnets with a /26. All right. So what are we saying? That this IP address is asking for us to subnet so that we can get the number of subnets. All right. We can get the number of subnets, and the number of subnets will be allocated to the different networks. How are we talking about different networks? This is 1, 2, 3, 4, 5. 2 raised to the power of what will give you at least 5 subnets. So if you do 2 raised to the power of 3 will give you 8. 2 raised to the power of 4 will give you what? 16. 2 raised to the power of 5 will give you 32, and so on and so forth. That is how you continue to go until you get to where you're going to. But in this particular case, You see what they are trying to say, that they require 10 subnets with the largest subnet requiring 40 addresses. So we have been given an area of concern, 40 addresses. 2 raised to the power of what will give us at least 40 addresses. Okay, that's where we now say 2 raised to the power of, if you say 5, will give you 32. It's going to be like 6. Okay, so that's how you do your subnetting. Now, let's look at VLSM, variable length subnet mask. Given the topology, 7 subnets are required. That is 4 LANs and 3 WANs. And the largest number of hosts in the building D with 28 hosts. That is, you have building A here, building B, building C, building D. This has 25 hosts, this has 20 hosts, this has 15 hosts, this has 28 hosts. And you say a /27 mask will provide 8 subnets of 30 host IP addresses and therefore supports this topology. Now, when we say VLSM, what are we talking about? VLSM is like the word we call variable length subnet mask. So it means the length of the subnet mask does not vary. You can have variable length in the number of bits. Right? You can have in the number of bits. Right? So why then do we use VLSM? VLSM helps makes better use of IP addresses by allocating subnet mask based on the size of each subnet requirement. Like we've seen there, 28, 27, 25. This is particularly useful when different subnets need different numbers of IP addressing. Okay, that is actually, does it have some benefits? Yes, it does. Efficient use of address utilization and reduces wastage of IP addresses. Another one is it gives flexibility. Different subnets can have different sizes. And then it supports hierarchical network design as well. All right. Now, why are we talking about the variable length subnet mask? We're talking about it because we have looked at the boundary subnetting. In this boundary subnetting, you see we're subnetting from /8. /8 is a boundary, and then we do subnetting from there. Then we looked at /16. /16 is a boundary, and we do it from there. Then we look at /24. /24 is a boundary, and we look at that. Okay, but here in VLSM, you don't need to look at that particular boundary. You can have maybe a /26, /27, /28, anything that you want to get, and it will serve you what you need. All right. So if you look at this example that we are talking about, if you look at this example that we are talking about, it's saying that a /27 mask will provide 8 subnets of 30 hosts each. We are looking for something that will give us at least 30 hosts. And then you see /27 will give us at least 30. This one, we need only 20 here, but we have this. We need only 15 here, we have this. We need only 28 here, we have it. So you see, you have /27, 27, 27. But in VLSM, you can find a way to even break it even smaller so that you can save network. So, however, the point-to-point one network only require 2 addresses. And therefore, you are wasting 28 addresses for each of the total 84 addresses used. Why are we saying so? From what you see here, in /27, it gives us 28 IP addresses, right? But you see, we want to just connect this point to this point. How many hosts? 2 hosts. This point to this point, only 2 hosts. This point to this point, only 2 hosts. That's what we need. And when we come to use /27, we're only using 2. The remaining is just wastage. And that's the point that we are making. So applying a traditional subnetting scheme to this scenario is not very efficient and is wasteful. So what do you do? What do you do? VLSM was developed to avoid wasting of these addresses by enable us to subnet each subnet. So how does it happen? Now, the left side displays the traditional subnetting scheme. That is the same subnet mask, while the right side illustrates how VLSM can be used to subnet a subnet and divide at least into 8/30. Now, let me make you understand. The regular one that we use for /27, it divided the subnet into 30 hosts each. How many subnets? 1, 2, 3, 4, 5, 6, 7, 8. 8 subnets, and each of these subnets has 30 hosts equally. And you see, equally. But what we need for this network, we only need 2 blocks, 2 IP addresses, and how many networks? We need 1, 2, 3 networks. So we need two IP addresses. So what we are saying, we can pick one of these subnets. We can pick maybe this subnet, for instance, and then resubnet it. That is where VLSM comes in. Resubnet it into something smaller. And that is how we've resubnetted this one. How then do we resubnet? You say you have /27. That means 27 bits are on. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Then 25, 26, 27. Is that not so? Then the remaining are zeros. How many remaining? 28, 29, 30, 31, 32. Now, this remaining that are remaining, how did we get this number of subnets? You see, these are the bits that are borrowed, 3 bits. So if I just do 2 raised to the power of 3, it will give me 8. That is how we got to know the 8 number of bits, 8 subnets, sorry. And each of these subnets will have how many IP addresses? Let's count. This is 1, 2, 3, 4, 5. So we do 2 raised to the power of 5 minus 2. 2 raised to the power of 5 is what? 32, right? 32 minus 2 will give us 30. That's why we have 30 hosts. You see the 30 hosts that you have. That's how this was gotten. Now, we want to do our subnetting or resubnetting. What do we need? We only need 2 IP addresses, 2 usable IP addresses. So if you remove broadcast and you remove network, then you will have 2. But if you add them together, you have like 4. So I will do 2 raised to the power of what will give me at least 4. So I know it's 2 raised to the power of 2 will give me 4. So this 2 here is the number of zeros that I need. So I know I'll need this 0, I'll need this 0. Then I'll convert the remaining. I'll convert this, I'll borrow it to the network portion. I borrow this 3 to the network portion. If I borrow this 3 to the network portion, that means if I do 2 raised to the power of 3 that I've borrowed, I will still get another 8 subnets. 8 subnets, each one will give me what? 4 IP addresses minus 2 will give me 2 IP addresses. That is how we got these ones that are broken down. Okay, so you see you have 8 subnets to give you two usable IP addresses. So you will carry 1, allocate in this, carry another 1, allocate here. Carry 1, so you now allocate them here. So now it's going to be slash what? Because we have borrowed this 3, this is 7, right? Then you have 8, this 27, 28, 29, 30. So our IP address is now going to be /30, no longer /27. That's why if you see this IP address here is a /30, you see this one here is a /30, you see this one here is a /30. So the concept of the VLSM is just to let us know that you don't need to rely on the boundary subnetting. You can still go down and resubnet until you get what you need. So using VLSM subnets, the LAN and interrouter networks can be addressed without unnecessary waste, as we can see here. So you see in this particular router 1, I can have in this network a /27 because I'm going to have a lot of hosts. Maybe I have 25 hosts. I'm going to have a lot of hosts. But you see between here and here, I'm using a /30 because I only need 2 hosts. So you see where I need 2 hosts, I use a /30. Where I need more hosts, then I use what I have there. Okay, how about in the IP version 6? How do you do the subnetting? It's a bit different. Remember in the IP version 6, we said that it has 2 portions, the network portion and the host portion. And the network portion has 64 bits. Then the host portion has 64 bits. Under the network portion that has 64 bits, we have the global routing prefix, which carries 48 bits. Then you have the subnet ID, which carry 16 bits. So any subnetting that you're doing, you do in that. So a separate subnet field in the IP version 6 global unicast address is used to create subnet. And the subnet ID field is the area between the global routing prefix and the interface ID. Okay, so for instance, you have a particular IP address 2001 DB8 ACAD /48. Now, /48 is trying to tell you here, look at this /48. /48 is telling you that this is just the global address without being subnetted. Okay, and that's why we said every is best to always use /64. All right. So /48. Now, if you do like that, global routing prefix with 16 bits of subnet ID, if you add it, then it will now increment and give you a /64. So that will now allow about 65,536 different /64 subnets. All right. So that is it for that one. Now, another example says, assuming you need like 5 subnets, one for each LAN as well as for the serial link between router 1 and 2. Between this router and this router, you need an IP address for it. And you see in IP version 6, we're saying we're using /64 all through, right? So if we're using 5 subnets that are located, all you just need to do is you pick from the first subnet and then pick the first 5 addresses. That's just all. Pick the first 5 addresses and then you allocate. You don't need to go and start breaking the subnets like we did in IP version 4. So the 5 IP version 6 subnets were allocated with the subnet ID 001 through 005, each on /64. All right, so that is how it is. All right, so I pick this one. You see, this one takes 001, this one takes 002. All right, this one takes this is 4, this is 5, and then this one takes 3. All right, so that's just it, nothing too much. So once you do that, you can apply it to your router. Okay, So finally, let's look at structured designs. So in IP version 4 network addressing planning, you are a network administrator and you want to design the IP structure for your network. All right. So IP's network planning is crucial to develop a scalable solution to an enterprise network. So to develop an IP version 4 network-wide addressing scheme, you need to know how many subnets are needed, how many hosts a particular subnet requires, and that requires that are part of the subnet, which part of the network use private IP addresses, and which part uses public address, and many other determining factors. Okay, so examine the needs of an organization's network usage and how the subnet will be structured. Now, perform network requirement study by looking at the entire network to determine how each area will be segmented. Determine how many subnets are needed and how many hosts per subnet as well. And then you determine the DHCP address pool and the layer 2 VLAN pool as well. So within a network, there are different types of addresses that require addresses. You have like your end user clients. That is where you have your phones, your laptops, your desktops, your IP cameras, your printers. You know, most of them use DHCP to get their IP addresses, and that is to help reduce errors and the burden on the network and so on and so forth. Okay, then in IP version 6, it uses DHCP version 6, or it uses SLAC. SLAC means stateless auto addressing configuration. Okay, then you have another device that uses IP, that's the servers and the peripherals. And this should have a predictable static IP address, which means you don't use your DHCP to assign IP addresses for them. So you give them IP addresses physically. So if you have a sub oh, sorry, my network skipped. Sorry about that. So I think we're back. Let's just continue. Sorry about the break in transmission. All right, so we're talking about device address assignment, and we talked about end user clients that require devices, and then we talk about servers and peripherals as well. Then servers that are accessible from the internet. Okay, so servers must have a public IP address, most often accessed using NAT. All right, then you have intermediary devices as well, such as your routers, your switches, and so on and so forth. All of them require IP addresses. Then you have your gateway routers, you know. So when you are designing your IP plan, you need to make plan for even this set of devices. Okay, that is very, very important. All right. We have finished what we have for today, unless maybe we have questions. If you have a question, you can raise your electronic hand and then we will answer. So while we take our questions, we're going to take our attendance. All right, Ahmed Jimo, you can begin.
All right, good evening, our instructor. Thank you for the lecture. It was quite interesting.
Thank you.
My question, I just need some clarification regarding the subnetting. I don't know how, if assuming I have two routers on a network and I want routers will be on their own IP address. So how will I determine that this is the subnet that they belong to?
All right. So let's assume that I have a subnet of 192.168 dot, let's say 0.0. Let's say I have /24. And I have, like your question, you have two routers. Okay. Let's say this is router 1, this is router 2. This router is connecting to maybe faculty A. All right. A particular faculty. This one is connected to another faculty. In fact, we can even add more. This is connecting to another faculty. This is connecting to another faculty. So you have about 4 networks. All right. Then these routers are interconnected to each other. So how many networks do you have? 1, 2, 3, 4, 5. So we have 5 networks. Now, how do I subnet this block to give me 5 networks? My formula is 2n for networks and then 2n minus 2 for host. So 2n for networks is 2 raised to the power of what will give me at least 5. That is 2 raised to the power of 3 will give me 8. Is that not so? So this /24, I will need to break it into 8. This 24 means that 24 bits are on. So I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Then the remaining are zeros. 1, 2, 3, 4, 5, 6, 7, 8. But from my formula here is 2 raised to the power of 3. I need to borrow 3. So I will now count 1, 2, 3. That means I am borrowing these 3 bits to the network portion. All right. I'm borrowing, so I'm turning these 3 to these zeros to be 1. I'm borrowing them. So if I turn them to be 1, my block is no longer going to be /24. How many bits will be on now? 25, 26, 27. So it's going to be like /27. Now, in each of these /27, how many hosts am I going to get? If I check here, how many bits are remaining? 1, 2, 3, 4, 5. So if I do 2 raised to the power of 5, this formula here, 2 raised to the power of 5 minus 2 will give me, this is 32 minus 2 will give me 30. Yeah. So that means I can have 30 IP addresses here, 30 IP addresses here, 30 IP addresses, 30 IP addresses, and then here, 30 IP addresses. And then I will even have some other subnets. But where VLSM comes in is saying that if I am to connect this router and this router, I only need 2 IP addresses. Why then do I need to give a whole /30? That's when it says, okay, you can resubnet the IP block of this /30. Because here it is giving you 8, 2 raised to the power of 3 will give you 8 subnets. Each of those subnets carries 30 IP addresses. So you assign any one of the subnets to any of this, but you start from the top going down. You start from the top going down. So the one that is connected to this, you can resubnet it. So you can, let's say you have /30 192.168.0.0, let's say you /27, and you want to subnet it into /30. That means you only need 2 hosts, 27 bits, which is in this case. For you to get 2 usable IP addresses is 2 raised to the power of 2. Is that not so? So we'll give you 4. So how many bits, how many zeros? 1, 2. So I'm going to borrow 1, 2, 3. So this is it. I'm borrowing this one. So it's no longer going to be /27. It's going to be /30. You understand? So the question of which IP address to allocate is up to you. You can just start from the top going down and you begin to allocate to the different faculties. I hope that answers the question. All right. Thank you. The next person is Maxwell Monday.
Not sure.
Maxwell Monday. Okay, it's not available.
Kind
The,
of
the next person is
lie inside there.
the next person is Dr. Oshwo Stephen. Dr.
Good evening, sir.
Good evening.
I just my question is just a simple question.
Okay.
Subnetting a subnet,
Mm.
won't it slow down a network?
And the answer is simple. It will not slow down the network. In fact, it will even make your network more efficient, more faster. Because it's like saying you have in a class, if you are okay, you are a lecturer, and in your lecture, you go to take lecture, and there are 1,000 students in the class, and you are supposed to teach 1,000 students. The efficiency you're going to get when you break this 1,000 students into a small group of 100 is going to be different. Okay, so subnetting makes your network more efficient because you are breaking the broadcast domain. There's no more broadcast. The broadcast is reduced rather. Okay, the broadcast is reduced, and even if there's a problem, it is easier to manage and things like that. Okay.
Okay.
No.
So, sorry, in addition to that, how
Mm.
will I connect if I'm having the one gateway for
Mm.
all the subnets?
Yes.
How will I connect this subnet to that one gateway?
Okay.
Assuming
Now,
that the gateway is a link to the net.
all right. Now I have. Okay. Let me try something. Let me see if I can get a blank screen. Just a minute. I'm coming. Trying to see. To see if I can get. Anyway, let me see if this whiteboard will work. I wanted to see if I can load a whiteboard and then do some diagrams for you guys on that. The concept, okay. Right. Now, if I have a router here, this router is connected to the internet. This is the internet. And that's like your default gateway. And then this router is connected in your network to the switch, maybe your core switch. And this core switch is connected to different faculties and different locations. Okay. Now, with this that you have here, your question is saying, won't the subnet affect it? It will not affect because maybe you assign the first subnet here, the second subnet here, the third subnet here, the fourth subnet, the fifth subnet. Inside this switch, we are going to talk about a particular topic called VLAN. Okay, we're going to look at the topic called VLAN very soon. We have not reached that point where inside this switch, you can configure for each subnet, you will configure a VLAN, a virtual LAN for each of the subnets. And once you are able to configure a virtual LAN for each of the subnets, your connection will be much better in that particular case. All right. So based on your question, you are saying whether it will affect it. No. In fact, VLANs or subnetting will even make your network better. Even if you have one default gateway, the router is going to now do the internal routing. Okay, that's why it is called a router. So anytime traffic comes into the router, It comes into the router. The router does the internal routing and decides where to forward the traffic. All right. The next person is Obiasen Isaiah.
Good evening, sir.
Good evening.
Okay, I have a question, then I have an observation.
All right, please.
My question now.
Okay.
No, this lecture, I believe we are still going to do the second part, because from on my profile, I saw CCNA1. So I believe when we are through this CCNA1, with me we are still going to 2 and we are still going to 3. That's question number 1. Then number 2, sir. You know, this program is we those of us that are participating, we know the stress that we pass through because of the benefit we are still going to acquire from it at the end of the day. But sir, I'm sorry, I just want to appeal. If there is a means you can communicate the schools to encourage the staff, because when it comes to money, or capital or money or financial responsibility, I want to say, sir, that some management usually dodge. I believe they are supposed to encourage the staff that are participating in this program, because at the end of the day, the feedback is still coming to them. What you are learning here now, the feedback is going to the student at the end of the day. So because Cisco is a very good aspect as far as competence is concerned, that is why I have interest in it. So please help us communicate the schools so that they can encourage us in terms of finance. We use our money to buy credit, to buy data, and we bought candles. Look at the time we have spent now on this lecture between 8 and 8:30. We are supposed to be on our bed, but because of the interest we have in it, we are participating, we are listening. Even the way you are delivering your lecture encourages those of us that are listening to it. That is why we are irrevocably committed to the task. So the school should do the needful, so that when they do the needful, they are the one that will repeat at the end of the day. Thank you, sir.
All right. Thank you very, very much, sir. I will do my best to convey your message. And I'm also sure that you have even your directors, your management staff also partaking in this training. And I'm sure some of them will actually get the message directly. But I will still do my part and convey your message. Thank you so much. The next person is Ojo Olufemi Anyo.
Good evening, sir.
Good evening, sir.
Thank you for the lecture.
You're welcome.
I quickly want to ask, okay, let me contribute this way. I want to say to my colleagues that even going through this lecture, we still have to, subnetting is one course that needs practice. Just like when we are doing binary conversion, you need practice to understand this thing very well. So I will employ us that at our own pace, aside what the lecturer is doing, we need a lot of time of practice for better understanding of this course. Okay, to my question, sir. I quickly want to ask, if I am given a particular a network address, and I am asked to subnet that particular address. And the question says further that I should use the first IP address in the third valid subnet. Am I still going to consider the original network address to calculate my valid subnet?
All right. So if I'm being given an IP address to subnet.
Yes, sir. I mean network address.
Yes, a network address to subnet.
Yes, sir.
and I did my subnetting, for instance, we have done this one. And based on this subnet, we saw that we can get about 8 small subnets from inside. The first subnet is subnet 0.
Yes, sir.
Subnet 0, then you have the network address. Subnet 1, you have the IP address. Subnet 2, you have the IP address up to subnet 8. You have the IP address.
Yes, sir.
If your question is saying you are to assign the third subnet to maybe Faculty of Education, this is the first subnet, second subnet, this is going to be the third subnet, then you will now assign this network address to Faculty of Education. Because this topic is very, very important. When we meet tomorrow, I'm not going to go into the next topic. I'm still going to talk about subnetting, so that I will give you so many other
practical examples. Okay.
so many other examples, and then see how we can see these scenarios, because I know some of us probably may not have understood this very well. Some of us may have the idea, and a few may have understood very well. So maybe tomorrow we will still look at examples and how to go about this subnetting, and then how you can assign to, if you are given a block, how you can assign. We can pick a particular institution, for instance, and then we will get an IP block, and then we will do the subnetting based on the faculties and the departments and the users. We will do that hopefully by tomorrow. Okay, so maybe when we come to do that, we throw more light.
Thank you very much. I will much appreciate that. We should be able to see the practical application of it. Thank you very much.
All right, you're welcome. You're welcome. All right, I see Maxwell Monday. Maxwell Monday, you can ask your question, then Kabir Murtala will close.
Okay, sir. Thank you so much.
Those who are still signing your attendance, I think the attendance have closed. So just to let you know that those who have not signed, okay, but I can see everybody have signed. All right, everybody have signed. So go ahead, please, Maxwell.
Okay, sir. More grace to you, sir. Actually, the question I was about asking you, someone also just asked the question. I was just about thinking of putting down my hand, but practical application of this subnetting. You know, having scenarios of the variable length subnetting and all that in practical terms. So you've already emphasized that we are dealing with it tomorrow in more detail and clearer examples. Right. So I think that has solved my problem.
Thank you very much. The last person for the day is Kabir Murtala.
Sir? Hello, sir.
Yes, sir.
Yes, can you hear me, sir?
Loud and clear.
Oh, thank you very much, sir. I want to appreciate the way you are communicating with us, especially with this practical. You are trying to put the practical into theory so that we can understand. And from this, especially this subnetting you have just discussed, from my little experience, in order to add to this environment, I think subnetting is just a way of managing our IP address so that we don't have wastages. So that at least we can manage this IP with respect to wherever we want to send this data or messages in the network. So I think with more practicals, at least it will also go a long way. Because I can see the way you are explaining, complexity is setting in, and just like you said, sir, that we are going to be understanding, and just like what one of us also said regarding the working with the binaries, since we know our computer understands machine language, the binary. So it's very important if we can also do some of the practicals. But in summary, all in all, the subnetting is just the way we can manage our IP address so that we don't waste them on the network. so that it will not just be overflooding and overflooding, especially when we are doing this issue with managing of maybe one to a particular IP address. We are assigning kind of, how do I call it? This issue of unicasts, maybe one to a particular system. You are assigning, you are giving privileges to some certain users with respect to their machines or their IP. Since we know that IP address is the way we can tag a system, or if a system is requesting for a particular request from either the source or the destination. I just want to appreciate you, sir. You are doing very, very, very well. Thank you, sir.
All right, thank you very much, Kabir Murtala, for that.
Yes, sir.
So before we close and end it for today, there are just 3 announcements I want to give you. One, tomorrow will be the last class that we have for the year. So after tomorrow, we may not be having our classes again until next year when we are back. Secondly, those of you who have not subscribed to the YouTube channel, I would strongly advise that you subscribe. There are other training videos that I am doing for others, and I'm uploading on the same YouTube channel. So you may find it very, very beneficial. So even this particular classes, I still upload it on the YouTube so that you guys can always run through it and follow up for questions in case you do have. So if you have not subscribed, please, you do well to do so. If you have any question and probably we have passed the class, you can always drop it in the comment section. I will see it and then I'll be able to respond to you. And then lastly, I am going to be enabling your checkpoint exams. Most of them have been enabled. I think the first one was disabled, so I'm going to enable it also so that you will all be able to do. For those of you who will be able to finish everything, you are still encouraged to do so. All right, you are still encouraged. If you can finish everything, fine. I don't have a problem with that, but I want to encourage everybody to try and finish before time. Okay, finish as we move. Thank you very much and have a very good night, right?
Hello, sir. Hello, sir. Before you close, hello, sir.
Thank you, sir.
All right.
Hello, sir.
Very much,
Yes.
sir. We do appreciate
Hello,
it.
sir.
Yes.
I just want
Thank
to
you.